In this lecture video, we'll be understanding Hurwitz criterion, special case 1. So the topic which is covered in this lecture video is numerical based on RH criterion, special case 1. If the first element of any row of the Routh array is 0 and the remaining row elements contains at least one non-zero element, then that case is called as special case 1. I'll repeat once more. The first element of any of the row of Routh array is 0 and the same remaining row contains at least one non-zero element, then that case is called as special case 1 of Hurwitz criteria. Let us understand this special case 1 and let us see how we can overcome this difficulty by considering an example. Predict the stability of the system having the characteristic equation h to the power of 5 plus h to the power of 4 plus 2s cube plus 2s square plus 3s plus 15 equals 0. So whenever a characteristic equation is given to us, we have to identify the highest power of s. In this case, it is 5. So write down h to the power of 5, h to the power of 4, s cube, h to the power of 2, h to the power of 1, h to the power of 0. Next, we have to start filling the Routh array. The first two rows of Routh array will be taken from the characteristic equation itself. The coefficient of characteristic equation will be directly considered over here. The coefficient of h to the power of 5 is 1, which is taken as it is in the first row. The coefficient of h to the power of 4 is again 1. It will be taken in the second row. The coefficient of h to the power of 3 is 2, which is taken again in the first row as a second element. The coefficient of h to the power of 2 is 2, which is taken in the second row as second element. Similarly, we'll be filling 3 and 15. Next, we'll start filling the other elements in a Routh array by applying the formula. To fill the row of h to the power of 3, we'll use a formula. 1 multiplied by 2 is 2 minus 1 multiplied by 2 again is 2 divided by 1. So 2 minus 2 is 0. 0 by 1 is 0. 0 by anything is 0. That is how we get this. Next, 1 multiplied by 3 is 3 minus 1 multiplied by 15 is 15 divided. So 1 multiplied by 15 is 15 divided by 1. So 3 minus 15 is minus 12. So the value which we get is minus 12. After this, we don't have any rows or any elements here, that those will be considered as 0. If we don't have any elements, it will be considered as 0. So anything multiplied by 0 is 0. Now if we observe, we have got special case 1. The first element of a row is equal to 0 over here. So when we get this kind of situation, then what we have to do is we have to replace a small positive number called as epsilon in place of this 0. So what we have done is, in place of this 0, we have substituted a small positive value called as epsilon. Next, after that, we'll start filling the array. To get this value of h to the power of 2, epsilon multiplied by 2 is 2 epsilon minus 1 minus 12. 1 into minus 12 is minus 12. So minus 12 into minus is plus 12. So that becomes 2 epsilon plus 12 divided by epsilon value. The same value is being written over here. Similarly, epsilon multiplied by 15 is 15 epsilon minus 1 multiplied by 0 is 0 divided by epsilon value. So 15 epsilon minus 0 is 15 epsilon divided by epsilon value. Epsilon and epsilon will get cancelled and will be left out with 15. Next, we don't have any other elements over here, so that will be treated as 0. Anything multiplied by 0 is 0. So we get this value as 0 over here. After this, to get the value corresponding to h to the power of 1 to that particular row h to the power of 1, 12 epsilon plus 2 epsilon plus 12 divided by epsilon multiplied by minus 12 minus 15 into epsilon divided by 2 epsilon plus 12 divided by epsilon. So that is the value which we have got here. Next, 2 epsilon plus 12 divided by epsilon multiplied by 0 is 0. Epsilon multiplied by 0 is 0. 0 by anything is 0. The next value which we get will also be equal to 0. Similarly, we'll try to find out the value corresponding to the row h to the power of 0. For that, let us consider this entire value, whatever we have got, this entire equation, whatever we have got, let us consider that as x, example x. So to get this value corresponding to the h to the power of 0, x will be multiplied by 15. So when 15 is multiplied by x, the value which we get is 15x minus 2 epsilon plus 12 divided by epsilon will be multiplied by 0. When it is multiplied by 0, it is 0 divided by x value, x. So 15x minus 0 is 15x. So 15x divided by x value, x and x will get cancelled. So the value which we get is 15. The same thing is being written here. To avoid unwanted complications, I have considered this entire equation as x. Now, if we observe, when the first element in a row is equal to 0, we have replaced that element 0 by a small positive number called as epsilon. After this, we will apply limit epsilon tends to 0 wherever epsilon comes into picture. H to the power of 2 as well as h to the power of 1. To these two rows, we'll be applying limit epsilon tends to 0. So when we apply limit epsilon tends to 0 for 2 epsilon plus 12 divided by epsilon, it becomes, so what we have done here is, we have taken epsilon as common. So when we have, when we take LCM of that, 2 epsilon plus, let me write it clearly, 2 epsilon plus 12 divided by epsilon is the value which we have got here. So what we have done is, we have splitted that. So 2 epsilon divided by epsilon plus 12 divided by epsilon, we have splitted like this. Epsilon and epsilon gets cancelled here. So we'll be left out with 2 plus 12 divided by epsilon. The same thing is being written over here. Now, 2 plus 12 divided by epsilon, when we apply limit, this epsilon value becomes equal to 0. So 12 divided by 0, anything divided by 0 gives us infinity. Infinity plus 2 is again infinity. So we have got plus infinity over here. Similarly, we'll be applying limit for the value which we have got for h to the power of 1 row. So when we apply limit, we will get limit epsilon tends to 0. We have simplified this equation. So when we have simplified this equation, we have got as minus 24 epsilon minus 144 minus 15 epsilon square divided by 2 epsilon plus 12. So when we apply limit to this, we'll get 0 minus 144 minus 0 divided by 0 plus 12. So wherever epsilon is there, we'll be replacing it with 0. So we'll be getting minus 144 divided by 12, which is equal to minus 12. So based on that, whatever values we have got, we are substituting that in our route array. So in place of h to the power of 2, we have got in that the first element there we have got as plus infinity. We have replaced that with plus infinity. Next, we have got minus 12 over here. So the minus 12 is replaced, or it is placed in place of h to the power of 1 beside h to the power of 1 as a first element there. Now, if we observe the first column of route array, we have got plus 1, plus epsilon plus infinity minus 12 plus 15. If we clearly observe, there is two sign changes. There are two sign changes. From positive infinity to minus 12, there is one sign change. From minus 12 to plus 15, there is one more sign change. So because there are two sign changes here, the system is said to be unstable system. Even if there is one sign change, the system is said to be unstable system. So because there are two sign changes here, the system is said to be unstable system. I hope that you have understood special case 1 of RH criteria. Thank you.